Hello students, welcome to today's session. So today we will be discussing some questions based on to the topic of organic chemistry. So since last many days I am getting this sort of a query that if a given substrate is containing more than one type of a functional group and the reagent which is supposed to attack with that particular substrate can attack all of those function groups there in the substrate, then which way the reaction has to proceed? So this is a very genuine query which generally come in front of us in while solving any problem of organic chemistry, because in the organic reactions there could be possibility of parallel reactions and you can get multiple products, but out of those multiple products you have to pick the major product which is generally asked in the problem. So before I go into the discussion, I really would like to thank you all people using this hashtag chemistry with Gurpreet sir. Use this hashtag wherever you are studying as much as you can, because together we can make this channel more popular. It is only because of your support and love. I'm putting all these videos in front of you, and I really would like to thank you once again. So come on, let's have a discussion of this particular question. So in this question, the fellow who has sent it, he was little apprehensive that which way the reaction has to proceed in this particular question. So you have to identify the major product. First thing is this. Now let us see what exactly it is to be done in this particular problem. So first you have to see that there is a alcoholic part here, and this is the ether part, if you could see, and you also would have alkene. So this way it is very interesting, and it is supposed to attack with H positive. This is what you are supposed to treat it with. Now before I go into the discussion, first always have to remember, whenever in any reaction the thing is to be attacked with H positive, before you get with the final product, during the mechanism of that, before reaching the final product, you have to abstract H positive as well. This is first thing which you always have to remember, that H positive is added before you give the final product. You have to deprotonate it before giving the final product. This is one thing which you always have to remember. Now let us go into the discussion. Now here what we are able to see here is that you would be having a lone pair. Oxygen is containing lone pair, and these lone pair can be attacked by H positive. So would H positive be attacking this lone pair? This is the first thing which would come in your mind. And second is, would it be attacking the ether part, ether oxygen, or would this be attacking the H positive would be attacking the pi bond? So these are the three things which would come in your mind, and it is a very genuine thing which, and while addressing these questions you should go with all this, and once you start doing it, and after you get the products, you automatically would get the feel that which among this is the major product, because organic comes with feel, as I used to tell to my students. Let us go with one by one by each of these steps. So if in case the H positive attack this lone pair, now the first thing which you would get here is that this would get a positive charge. Very simple. So now you have to do the dehydration. This water would go out, and once this water would go out, you would get a carbocation here. And very obviously you would be seeing that this carbocation feels like, to me as well as to you, that it gets stabilized by the pi bond. Fair enough, it is nothing wrong in it. It is being stabilized, and it's a tertiary carbocation. It is being stabilized by the pi bond. Fair enough. Thereafter, what you have to do before you give the final product, you have to do the deprotonation. And deprotonation always would happen from a carbon next to the carbocation. The carbon carrying positive charge, next to that carbon, the deprotonation would happen. So this H positive go out, leaving its electron there, so that this pi bond can be generated. So in one way, you feel like that there could be a product formation like this type. And this product, to me as well as to you, feel like quite a expected one, because you could see a resonance taking place this way or reverse way. The resonance is taking place. So, and the examiner is going to give you this as one of the option, and they gave it as a option. To start with, generally we opt for the A, but it is not the right thing. Let us go for the other exploration also. In that sense, organic chemistry is very interesting if you start getting the feel out of it. Now, the other one is that you have lone pairs, and this H positive can attack this lone pair as well. Now, if I would do so, so what I do get here is a positive charge, and this is CH2, and this is being, sorry, let me write it like this. This is the positive charge which we get, and here you have a pi bond. Now, here also, what generally people do a mistake. Most often, many of you people would do this mistake, which you should not, that uh, there is a pi bond here and it is a positive charge. Now, as soon as you see positive charge in conjugation with pi bond, people have the habit of doing the resonance. Now, this way of doing the resonance is a wrong one, because if I do so, what I would end up getting here, I would end up getting here around oxygen, then there would be 10 electrons, which is not possible. That is not a bona fide Lewis structure. Generally, people do this mistake. This is wrong interpretation, because this way, if I do so, that there is already a lone pair is still there, because one of the lone pair is being attacked by the pi bond. Around this oxygen, now you have 10 electrons, which is not possible. It is not a bona fide Lewis structure. So it is a wrong way of interpreting the thing. So this is one important thing which generally people do the mistake. So this is wrong, and this also is wrong. Now let us go further exploration into it. Let me use the another page here, where we use this one H positive attacked here, and you end up getting a positive charge onto this one. So this is what you have achieved here. Now the other thing which you can think about it is, because it's a ethereal oxygen carrying a positive charge can undergo ring opening. So ring opening can go from this side or this side. But in doing so, you have to see into it. This is sp2, this is sp3, and we know that electronegativity of sp is greater than sp2 is greater than sp3. So once there is a positive charge, because if I would open it from this side, the carbocation which I am going to get would have less stability as compared to the carbon carrying the sp3 carbon. So I just would want to do the opening this way. If I would do this way, what I would get here is something like this. So you would get a compound of the type this way. So here you have a OH, and you have this pi bond, and this is CH2 positive, which is not a very stable carbocation because it's a primary carbocation. Now the point is that if in case you think it this way, the other thing what you end up getting here, again you have to do the deprotonation, and deprotonation has to happen from the carbon next to the C positive. So from here the H positive goes out, and you would get this type of a moiety. So this particular thing which we have received is again you would feel as if this is a quite a stable compound, because there is a possibility of resonance taking place here also. Now let us see into the, is this option available for us? This option, which is the first one, is available, which we attacked here, is there in the A option. And I could not see that the ethyl oxygen, by attacking the ethyl oxygen, there is ring opening, there is no option of ring opening. Now we are left with one more, that is the pi bond. Now let us explore that viewpoint also, that would, and then you would see which way it has to go for. So here you have OH, and here you have this one. Now the question is that if I would attack the H positive, would I be attacking it like this? That in a way, what I'm trying to say to you is that would I be making a positive charge onto this one, that I just would attack the H positive here onto the uh, this carbon is being attacked by H positive, and these two electrons went to this side. As a consequence, this would get a positive charge. Other way around is that if I do the other way around is, because in the pi bond there are two options available now, that I can attack the H positive. Beautiful question it is. I can attack this way. Then the carbocation which I am going to receive is somewhat like this. This is the another question which may come in your mind, that which way should I go. Now, the way which you should be selecting is the one which would make the carbocation more stable. So obviously, this is secondary carbocation, this is secondary carbocation, and this also is a secondary carbocation because it is attached to the two carbons, one on this side, another on this side. But the lone pair of this oxygen is definitely going to do the stabilization through the viewpoint of resonance. And as a consequence of that, what next structure you would receive here is, and there is OH group here, which I might have missed. So another resonating structure which you would receive is this one. And as a consequence, this oxygen is carrying a positive charge. Generally, people feel it as to be not a very stable compound. This resonating structure is not very stable. But I would mark it very categorically here. This is very stable, unexpectedly very stable. All those carbocations become very stable. All those resonating structures are very stable where oxygen carries positive charge, and along with it, its octet is complete. In this particular entity, you would see all the atoms are having complete octet. In the carbocation which I am showing here with the blue marker, this carbocation is not having the octet complete. The around carbon there are 6 electrons, but as a matter of fact, in this particular carbocation, the octet of all the elements is complete. So this is very important. So this means this is stable. So what I'm trying to say here is, let me write it once more for you. So we would be attacking the species, this pi bond from this direction. I shall be attacking this one so that these two electrons can go here, because by which you would get a carbocation which is quite stable. The carbocation got stabilized because of the resonance provided by the lone pair of electrons of the oxygen. So this carbocation is quite stable. Now, thereafter, what I am going to do in this next step can be the deprotonation. Now, how could I do the deprotonation? One way is I just would remove this deprotonation. If I would do so, why I have attacked it? That's a beautiful juncture. So it would not undergo deprotonation at this point of time. Now, what else we can think about? The other thing which you should have to now think about is the fact that from here, from this particular direction, you could also do ring opening because it's a four-membered case. Now, if I would do the ring opening like this, wow, if I do this ring opening this way, what I would receive? I would receive something like this. It would go this way, and I'm just making the way I have just shown above so that you could feel it with me that which way what way the sir is doing. So you would get something like this. You would receive something like this. This is still the OH, and now you would receive that because this particular carbon would now get a positive charge. This would get a positive charge. Now make it a point, if the carbocation which you have adjacent to that carbocation, there is OH group. There is OH group. So try to bring positive charge onto that carbon which is containing a OH group, just like in the case of pinacol-pinaclone rearrangement as well. So make it a point, when you have a carbocation, let me state it very categorically once again, when you have a carbocation and along with the carbocation there is a carbon which is containing OH group, then try to bring positive charge onto that carbon which is containing OH group. Why I'm saying it so? Because that way this lone pair of oxygen can stabilize it through the resonance, the way we did in the last slide. So what shall then I be writing it? I am making this structure once again for you so that you could understand it well. So I am just making it now 5-membered, because this also is 5-membered now, because this is 5-membered ring. 1, 2, 3, 4, 5, just for your simplicity. So here you would get a OH, and this is containing a positive charge. This is quite a stable carbocation. Why it got stabilized? Because now you can stabilize it with the lone pair, and once you do the stabilization with lone pair, what next thing you would get here? You would get a double bond and a 5-membered ring here as well, and here you would receive a positive charge. Again, this oxygen containing species is quite stable because the octet of all elements is complete. Octet of all elements is complete. Even though oxygen being electronegative is containing a positive charge, still it is quite stable. And the last step which we have to do is the deprotonation. Now, which way I have to do? This H positive would go out of the system. This H positive would go out of the system, leaving behind a 5-membered cyclic ring containing keto group, and along with you have a cyclic ether. Now we have to explore, would this be given in the option? Is it there in the options? Let me check this out. So now these two are very confusing. This one and this one is very confusing. Now make it a point here. What we generally may make a mistake while selecting this. At times people have done the question, but they selected the wrong one. So this is having less number of carbon atoms. Here you have 4 carbon atoms. Here you also would have 4 carbon atoms. So in totality, you need to have 8 carbon atoms in the final product. So here you have 5, 6, 7. So there are 7 carbon atoms. So 1 carbon is less. So this is wrong. So this is the most expected answer for this question. So this is the major product. Now we have to address why I consider it as a major. The major reason for that is because in the mechanism, the carbocation which we get 2 times is being stabilized by the lone pair of oxygen. So that is why I am considering it to be more stable. And the ring also have expanded because the 4-membered ring is less stable compared to the 5-membered. So this is the one question which I thought of placing in front of you because it is quite an interesting one. Now let's take one more question, although the video may become a little lengthy, but it is an interesting question to address here with. Now, before I go into the discussion, this is a more than one choice question. So this is a more than one choice question for IIT advanced type, but it would help all those people preparing for JEE mains and NEET. Now, in this question, again, the H positive is added. So before we give the final product, you have to remove the H positive. You have to, after once we get the product, we have major product. Now, what is being said about it? Select the correct statement involved during the mechanism forming major product of the above reaction. So let's first make the structure, make the compound, and then we'll see into it what the options are given to us. Now, first step is that you have to attack the H positive. Again, you have to address it with the viewpoint. Here, I would not be attacking it onto the pi bond. Why I would not be attacking it onto the pi bond, I will explain it the later part. So here, H positive is being attacked. So you would get what here you would get here is a positive charge onto the oxygen, and then you have to do its deprotonation. Water goes out, water would go out, leaving behind a carbocation of the type tertiary. This is a tertiary carbocation which we have received, and here you have a ethyl group. Make it a point, this is a ethyl part, okay. Now thereafter what I am supposed to do, if now one thing is that I just would remove the H positive out of it. If I would remove the H positive out of it, then I would get a product of the type this way. This is quite a expected type of a option given in the paper, because you could see a resonance can take place and it is quite stable in terms of the resonance. So there can be one option like this also. Other thing which we can think about it is that we have achieved this compound, this carbocation we have just received. Here you have double bond, and there is a positive charge here. This is a tertiary carbocation. Now I can do the resonance. If I would do the resonance, just see into it. If I would do the resonance, what next resonating structure do I get here? In the next resonating structure which I would receive here is something like this, and here you would get a positive charge, and here you have a ethyl group. Now the point is, which generally people miss, most of the time generally people miss to see that there are hydrogen atoms here also. There are one hydrogen atom at this place. Why I'm now showing it to you is you need to be little vigilant about these hydrogens. Now the fact is that if in a way I do from here, which we generally don't do, if I would do the ethyl shift here, if I would do the ethyl shift. Now, what next I can get here is that if I would do the ethyl shift, let me do it, then we will explain the things. Then, what next type of a carbocation which I would get? The carbocation which I am going to get here is a positive charge here. And this carbocation is still the way this one was stabilized by the resonance, this also is being stabilized by the resonance. Nothing, and it is still the tertiary one. Now, the last thing which we can now see into it, the hydrogen which was here can now undergo deprotonation. So, if I would do the deprotonation from this point, what next thing I would get? A positive charge here. Am I right? So, what next I would get here is if I would do the deprotonation, what next thing I would get here with is something like this. Am I right? And you have a ethyl. Now, in the process, what basically we have achieved? We have achieved a aromatic character or aromaticity came into picture, which would make it highly stable. So we have attained a aromatic ring in it, which would make it highly stable. So obviously, as compared to this product, if I would consider this as one of the product versus this product, now, if I would show this product, I would rate it, I would rate this more stable because of the fact that it is engaging aromaticity. Generally, we don't do ethyl shift, but in this particular type of a problem, I'm not left with any option. Now, let us see into the option that in a way will address many things. Now, what type of shifts are possible? I will be soon making all those videos: hydride shift, methyl shift, phenyl shift, and ring expansion. Based on that, we will be doing some. I will be placing some more videos in front of you. Now, in this particular, now we are almost through the question and we have reached to the answer that we have got this as one of the product, and this is the one of the product I have received with. So product has an aromatic ring. This is perfectly right. Mechanism involved ethyl shift. Yes, it do involve ethyl shift. Product has 6 benzylic hydrogen. Now, as a matter of fact, I always say to my student, more than one option questions are really fantastic because it in a way check many of the things. Now, what is benzylic hydrogens? Benzylic hydrogens are those which are next to the benzene ring. If I would say this is benzene ring or phenyl ring, next carbon which I am saying, this particular carbon next to the benzylic, next to the benzene, is said as benzylic carbon, and the hydrogens attached to that particular carbon is called as benzylic hydrogen. Now, how many benzylic hydrogens are there? One is this, two are there, and two you would get here, and two you would get here. So there are 6 benzylic hydrogens. So this also is a right statement. And one more option we are still left with. More than one tertiary carbocation is formed during this mechanism. Wow, this also is a very interesting one. This also seems like a correct one because it is tertiary carbocation came into picture 2 times. One here, if you could see, you get the carbocation here, and another carbocation which is of the type tertiary was here also. This also was a tertiary carbocation. So in this particular question, it seems like all the options are correct. A, B, C, D. All of these are correct. I hope you enjoyed today's session, and if in case you enjoyed it, do use this hashtag chemistry with Gurpreet sir. Chemistry with Gurpreet sir, as much as you can. Thanks a lot. Hope to see you in the next video where we will be placing some more important questions for upcoming NEET and JEE mains and advanced examination. Thanks a lot. Have a nice day. Take good care of yourself. Oh shit. Hello students, welcome to today's session.